Hello students, greetings for the day. I wish and I hope you are all safe at home and your home learning is also going well. It's been 5 weeks and today I come up with a new chapter, a new lesson. The learning objective for today is you will be able to understand the properties of parallelograms. This word parallelogram comes from another word which is parallel. What is parallel? You know which are parallel lines which never meet. So what is a parallelogram and what are its properties? So by the end of this session you will be able to understand the properties of parallelograms, and not only that, you will be able to apply the properties of parallelograms. Right. The family of parallelograms or the family of four-sided shapes. How many four-sided shapes do you know? I know the first thing that comes into your mind is rectangle or a square or a diamond shape to that matter. Okay. But where does the story of the four-sided shape start? Now, if a shape like this, what name do you give to this shape? It is not a rectangle, nor it is a square. Then what name should I give to this random four-sided shape? It is called as a quadrilateral. Now what are quadrilaterals? Quadrilaterals are simply four-sided shapes. Are there any other qualifications? No. So this is the rawest form of a four-sided shape. Okay. So beginning with the quadrilaterals. Now let me jump on to the next segment, which is parallelograms. Okay. Now if I take a quadrilateral in which the opposite sides are parallel to each other, then that shape will be called as a parallelogram. And by this time you understood why did parallelograms get that name. Now how many kinds of parallelograms are there? Before going into that segment, let us try to understand what are the properties of parallelograms. So for the first line to say any parallelogram is a quadrilateral, it's a four-sided shape, a four-sided closed figure. Now what are its properties? Property number 1. Its opposite sides are parallel to each other, like you can see here. Because the opposite sides are parallel to each other, they are equal. The opposite sides are equal to each other. Not only that, if you observe carefully in this parallelogram A, B, C, D, angle A is equal to angle C and angle B is equal to angle D. So, two properties I can tell about parallelograms. 1. The opposite sides are parallel and equal. 2. The opposite angles are also equal. So these are the properties of parallelograms. Okay. Does the story end there? No. We have much more to go. How many kinds of parallelograms are there? Let me say. In a parallelogram A, B, C, D, we know that the opposite sides are parallel and equal and the opposite angles are equal. But what happens if in a parallelogram each of the angle equals to 90 degrees? Then that becomes a rectangle. You can see the demonstration of a parallelogram changing into a rectangle over here. Just a slant turning straight, each angle becoming 90 degrees. So in a parallelogram, if all the angles are 90 each, then that parallelogram will be called as a rectangle. Let's go further. What are the properties of a rectangle? Number 1, It's a parallelogram. So all the properties of parallelogram will apply to a rectangle also. That means the opposite sides and opposite angles are equal. What else does it have? Each of the angle is 90 degrees. That's the additional quality that a parallelogram turns to be a rectangle. Okay. Let's jump into the next special parallelogram. Consider the parallelogram ABCD. Oh, I know that you recognize this shape. It is called as a square. Why not a rectangle? Can you call this shape as a rectangle? Yes, of course, I can call this shape as a rectangle. What are the properties of rectangle? Opposite sides should be parallel and equal. Yes, they are. And each of the angles should be 90 degrees. Yes, they are. So, can I call a square as a rectangle? Yes, I can. Only that a square is a little overqualified than a rectangle. What is the other qualification that a square has over a rectangle? Each of its sides, all the four sides of a square are equal. So, if in a rectangle, if all the sides are equal, then it becomes a square. So now, tell me the properties of a square. 1. It's a parallelogram. So all the properties of a parallelogram apply. We know the properties of a parallelogram. Opposite sides are parallel and equal. Opposite angles are equal. Along with that, each of the angle is 90 degrees and also all the sides are equal. So if in a parallelogram, each of the angle and each of the side, if all the angles are equal and if all the sides are equal, it becomes a square. Now, let me introduce to you another special parallelogram, which is a rhombus. Most of you may call it a diamond, but mathematically it's correct to call it a rhombus. Now, what difference does a rhombus make from a square? A square has all the four sides equal. Yes, even in a rhombus, all the sides are equal. But what difference does it make? If you carefully observe in a rhombus, opposite angles are equal. Are all the angles equal to 90 degrees? No. So, can I call a square as a rhombus? Yes, of course, because the opposite angles are equal. But does a rhombus become a square? No. So, now tell me what are the properties of a rhombus? 1. It's a parallelogram. 2. All the sides are equal. 3. Opposite angles are equal. They need not necessarily be 90 degrees each. So, now what did we learn? Let's memorize it again. 1. Quadrilaterals are the basic four-sided shapes. 1. 2. Parallelograms are the four-sided shapes or the quadrilaterals in which the opposite sides are parallel and equal and the opposite angles are equal. 3. Rectangles are parallelograms in which each of the angle is 90 degrees. 4. Squares are rectangles in which all the sides are equal. 5. Rhombus are squares in which only the opposite angles are equal.